Hi everyone, welcome to Physics with Ben. I want to use this video to tell you guys congratulations in your external exams this year. Okay, I'm here for us today again. This is a continuation on the video on Physics 3 WAEC 2025 Alternative A. So as I said in the other video, which you can find in the description, based on the instructions given, we can have as many experiments as we can from that instructions. For me, when I went through it, I discovered that we can perform like 3 experiments from that particular set of instruction. But something I want you to know is this: even though they give you all the apparatus on the D-Day, you aren't going to use all the apparatus. Again, some of the stuff that are listed in the blueprints, not all of them will be used on the D-Day. Then lastly, some that are not listed there, you will see them on the D-Day. For instance, on the D-Day of the experiment, if we are supposed to run this experiment, it is expedient we find the mass of the ruler, meaning you have to make use of the weighing scale. And if you see, the weighing scale is not in the blueprint. Good. So expect that. So the reason why I am so confident that this may be the experiments that majority of the materials listed, all of them are almost here. That is why I'm so sure of this experiment. So in today's video, I want to practically run the experiment step by step, and this experiment can be found in past question. This is the past question I'm using. This is the past question I'm using. It is found in June 2009, and June 2009, and then you can also find it. I wrote it somewhere. You can also find it in. Look at this. These are the years that contains this particular Bifilar experiment: 2009, 2017, and 2020. So without wasting more time, I'm going straight to the business of the day. Okay, I want to make this video very snappy, and so you can find the instructions to the experiment I'm running down beside the video you are watching right now. Okay, based on the instructions given, this is how our table of value is going to look like. This is it. And so I will run the first 2 values without skipping a step so that you can run the experiment. So first of all, we are supposed to measure the mass of the ruler. This particular mass of the ruler in the physics lab here is weighing around 173 grams. I'm sorry, my weighing scale is not here with me, but I will confirm that when I'm done with this video, and I will drop the value in it for us. So thank you. So the first thing we have to do, weigh the mass of the ruler and put the mass here in gram. Then next step, the mass you are seeing here, this particular mass here is 100 grams, and this is the sellotape that is used to seal it up there. In the description box, you can find a video link on how I set up this yesterday. Don't forget, I said you cannot run this experiment alone. 2 students per stand, or even 3 students. Okay, we want to run the first value. So we are going to reduce this length to 40. So we want to start with 40. So watch what I'm doing. This is where 40 is. 40 is around this place. So we have to take this up to this level. Good. So you take it up. You do the same thing on the other side. You take it up. So let's see if it's up to 40. Okay. observe the way I'm measuring it. This is at 90. If you observe this rope is not vertically straight. So we are going to adjust it so that it will be vertically straight. Good. So it is vertically straight right now. So that is the adjustment. So this one too must be vertically straight down. So we adjust it here. We take it up. So this is exactly 40. This is exactly 40. Take it up. Good. So let's try this one and see. This is exactly 40. That is 40 mark. Good. So at this point, we are going to displace this, and the number of oscillation is 20. Don't forget, the distance between the two loops is our D, and that distance is 80. Should we measure? This is on the 10 cm mark, and this is on the 90 cm mark. So if you place this, you see that the distance between the two loops is look at it, is 80. And this D, small d, 80, will be constant throughout the experiment. So without wasting more time, let us get to the business of the day. So here we go. Don't forget, as though you want to open the tap clockwise or anti-clockwise. So let's go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 15.0 seconds. So we record 15. 15.00. We want to be sure of what we are doing, so we find T2. So I reset my stopwatch. So let's do it for the second time again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time we got 15.56. 15.56. So we're going to find the average of that. That is 15.00 plus 15.56. That will give us 30.56 divided by 2. And our result is 15.28. So our T average is 15.28. How do we find our T period? The number of complete oscillation per unit time. So our period T is this value divided by 20. So we do 15.28 divided by 20. And that gives us 0.764. Let's leave our answer to 4 dp. 0.764. So how do we find our t-square? You square this value. So we square 0.764. You square the value. And if you square the value, you're going to have 0.584. So you record this the way it is appearing to 3 dp. So we repeat this procedure for second and the third and the fourth and the fifth time. we want to run the value 50. So we are going to reduce. Don't forget your 0 mark should be on top. We are going to reduce it down to 50. Down to 50. That is 50. We come back to this side, we do the same thing. Down to 50. Good. So while keeping the distance between the two loops constant. And so here we go again. So let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 18.03. So we record 18.03. Let's do it again. Okay, here we go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time we got 17.75. So record 17.75. So let's move to the next number, which is 60. So pull this down to 60. Don't forget to tighten this here so that you have a firm grip. So this 2 to 60. Take it down to 60. Good. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This time we got 19.34. So record 19.34. Let's find the second value out. So here we go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This time we got 19.19. 19.19. That's 70. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 20.56. So record 20.56. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 20.43. So this is the last value. So we are doing 80 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 22.06. 22.06. 22.06. Okay, let's do it again. The last value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time we got 21.75. 21.75. Now, observe something quickly. Observe something quickly. There's something called the trend of the experiment. In the same center, in the same school, in the same hall, not all candidates will have the same results. Although you may have separate stands of this. That is, if on the D day, this is what you will see. I'm just predicting. But one thing is very, very sure. What is that? The trend of the experiment. We call this the composite table. And these are the controlled values, controlled variables. If you can watch this column and this column, you observe that there is an increase. So between the height of the thread, the height of the bifilar means two loop, the height of the bifilar, the increase in the height is giving us an increase in time. So we could call this trend increase. So if you are going to plot a graph, your graph will definitely be something like this. This is the nature of your graph. Your graph will look like this. You can find any of this graph. Either one passing like that, one through the origin, or one this way. This is the nature of the graph you are going to have with this experiment. Why? Because it is an increase trend. Complete our table of values. So 18.03 plus 17.75. That will give us 35.78. 35.78 divided by 2. That will give us 17.89. So our period is what? This result divided by 20. This result divided by 20 gives our period on this column. So we have 17.89 divided by 20, and that will give us 0.895. Then we square this result. So we have 0.895 0.95 squared. That will give us 0.801. So our table of value is ready. So examiners may ask us to plot a graph of this against t, or a graph of this against t squared, or t squared against this, or t squared against any of this. So this against this, or this against this, or this against this, this against this. In any case, this is how your graph will look like. Why? Because the trend is an increase trend. So we are going to plot the graph and do the other deductions. So before I end this video, you have to state the precautions. What are the precautions here? You are making use of the ruler. So you state, I avoided error due to parallax while taking reading on the meter rule. That is number one. Number two, you can tell the examiners, I avoided air interference by closing all the air source. Because if the fans are blowing and the windows are open, you're not going to have accurate results in this experiment. There are other precautions that you can Google, but these two ones I just gave you, they are very, 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 very important precautions. So the remaining stuff that we have here, which let me just read them out. The next thing that we need to do in this experiment, we're asked to plot the graph of t squared against h. So we have to plot a graph of t squared against h. So we have to plot a graph of t squared on the vertical axis and h on the horizontal axis. I would love you guys to plot this graph and let me see what your result looks like. Find the slope for me, and then you will see in the comment section. We also asked in this experiment to determine the slope s of the graph and evaluate k is equal to s over q, and where q is given to be 2 over 25d squared. What is your d? D is 80, or you can convert the 80 cm to meters by dividing it by 100. And then last but not least, state two precautions. I already done that. Define the term couple. Couple as it relates to rotational oscillatory system. What is couple? Couple simply means two equal but opposite forces. Yeah, two equal but opposite forces connote a couple. For instance, when you are riding the bicycle, that is a classical example of a couple. And the way I was trying to turn this oscillation was also a couple. Like you see that there's a force going this way and another force coming this way. So we also have what's called moment of couple. Moment of couple is simply the product of one of the forces times the perpendicular distance. Bring it close, please. So if this force goes this way, and then from here to where this force is, there's a force here, then that is the moment of the couple. The product of one of the forces times the perpendicular distance. So they also ask us here to give two practical applications of couple in everyday life. When you are riding your car, you hold two hands on the steering. That is practical application of couple. When you are riding the bicycle, that is couple. To this, we have come to the end of this experiment. We plot the graph and then attach it to this video beside you, and you look at it and then you share to others. Expect video on question number 2 and question number 3. Don't forget to subscribe and share my content. Thank you and God bless you. Bye-bye. Okay, next up we want to plot our graph, and we are asked to plot the graph of t squared on the vertical axis and h on the horizontal axis. So what we need to do is to find the suitable scale for our graph. I have done several videos where I teach you how to plot graph. In choosing your scale, you have to consider the highest number the highest value and the lowest value on each of the axes. You must not necessarily start with 40, then 50. No, you have to start from somewhere, then you progress and you reach 40. You must not also start with 0.58. You have to start somewhere before you progress, you get to this level. Good. So we can reduce the values of t squared from 3 decimal places to 2 decimal places. In this case, this is a 0.58, 0.80, 0.93, 0.05, sorry, 1.05, and then 1.20 in that order. So quickly, I have gotten the scale for the vertical axis, and that is 2 cm to represent 0.2 units, and on the horizontal axis we have 2 cm to represent 10 units. So I will write it up here boldly as 2 cm to what? 0.2 units. And then down here we have it as 2 cm to 10 units. This is a standard WAEC graph. From this point to this point is 2 cm. From this point to this point is 2 cm. So it is in 2 cm. Both axes are 2 cm. Okay, let's plot. Let's draw the lines, the vertical lines, and then the horizontal line. Okay, if you say 2 cm, 2 cm times 0.2 times 6, you're going to get the highest value, meaning you have to move 6 pace, in pace of 6. So 0.2 times 6, that will give us 1.2, which is the highest value on the vertical axis. This is it here. So it means that this will cover. So you have your graph need to cover half of this, at least 1/3 of what is here. So let's verify that 2 unit equals to 10, 2 cm equals to 10 units can occupy 40 and 8. Okay, we are going to start from here. This is 10, 20, 30, 40, 50, 60, 70, 80. Good. So our line will go up here and come like this. So we draw our line here. This is the vertical line. Put an arrow up here and write t square / second square. Good. Next up, the horizontal line. I want to use pen so that to be very, very clear. You don't use pen on graph. Take notes. I am doing this because I'm a teacher, okay? So this is very clear. So right here we have 0.2, 0.4, 0.6, 0.8. So we are through the vertical axis, and don't forget to always start your graph with 0, 0. Very, very important. Right on the other side, this is 10, this is 20, 30, 40, 50, 60, 70, and 80. Don't forget that here is H/cm. Good. The units must be represented. If not, you lose half mark here. So right now, based on WAEC marking scheme, this is half, that is 1 mark. This is half, that is 2 marks. Correct, let's proceed. So the next thing to do on this particular axis here is to find the value for each small box. In that case, what do? We say 0.2 divided by 10. And that will give us what? 0.2 divided by 10 will give us, that will give us 0.02. 0.02. So this is the value for each small box on the vertical axis. The value for each small box on the horizontal axis is simply 10 divided by 10, and that is equal to what? 1. And so we are through getting that. Now, why is this very, very important? We are going to divide everything here by 0.02 to get the exact value on the graph here. And I'll just try one and then you see how we go about it. So we want to plot the graph now. When t square was 0.584, h was 40. So how do we go about it? 0.584 divide by 0.02. You see 29.2. 29.2 simply means you count 29 small boxes. So let's go. This is 10, 20, and then 29 is somewhere here. This is where 29 is. This point here. Good. So 29 against 40. This is 40. This is 29. So this is the first point. This is our first point. So we have plotted the first point. Look at it very well. If you don't want to confuse us, so just put it right here and then trace it, it will meet it, and then this is 40 and that is the point. Good. So you do that for all the values. And this particular pattern helps when we are dealing with decimal figures, decimal values. You don't make mistake. So we are going to replicate what I just did for all the values. So when t square was 0.80, h was 50. And this is the point. This is 50, this is 0, and this is where they meet. So you put a star here. We are through that point. Now this is 0.929 divided by 0.02. I got this figure. So we're going to round it up twice. This simply means this is 46.5. Then to the nearest whole number, 47. So you count 47 small boxes. So the 47th box is right here. Then that 47 box gives us 0.929. And that's against 60. This is 60. Look at 60 here. Look at 60 right here. So this is where they meet. This is a point. This is a point. So you put that and then that. And then last but not the least, 80 against this point. So we are done plotting our graph. So these are 1, 2, 3, 4, 5. And then this is 1, 2, 3, 4, 5. Look at that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now let's draw our line of best fit. Now take note, in drawing a line of best fit, always use a transparent 30 cm ruler, not this ruler, and not this ruler. I always break it when my students are using it. This particular one, I break it. This one, I also break it. Because see, you can't see anything on the other side. Do you see that? You can't see through it. And this one, look at it. So the line must go up and come down this way. See, it is too short. But this one, correct. So you see, you can see through. So your line of best fit must touch at least three points. I am already seeing, wow, this is 4 points captured. One is outside, I call it the black sheep value. When you go here, you capture only 2 points. If you go here, you capture only 2 points. So I will want to let go of this point. So that will go of this point here. That point is a black sheep value. So we have captured 4 points. So we draw our line of best fit once. Let's go. Good. That is your line of best fits. Do you observe something? I predicted 3 types of graph that you will likely get in this experiment. Look at them. The first, the second, the third. So in this case, we got the first graph, having intercept on the vertical axis. This is the intercept here. So if the question asks for intercept, this is where your intercept is. How can you get this value? 0.02 times the number of small boxes here becomes your intercept on the vertical axis. The next thing is to draw our big triangle. Take note, if your triangle is not big enough, you are going to lose mark for it. So I want to pick this point, and this point, and then this point for my triangle. Now, while drawing a big triangle, extend the tip here with broken lines so that you can easily trace good. Do the same thing at the top here. The same thing up here. Good. So right up here, this is your t square 2. Here is your t square 1. Here is your h2. Here is your h1. So the whole of this is change in h. The whole of this is change in t square. Your graph is complete. At this point, we want to calculate the slope of the graph. So the slope of your graph is equal to change in t square over change in h, which means t square 2 minus t square 1 divided by h2 minus h1. The value for t square 1 is 1.2 minus what? T square 1 is 0.4 all over h2 is 80. So you write 80 minus this value here. And this value here is 9. This is 19. 19, 20. 80 minus what? 19. So your slope is this. To the unit of up here is second square. Down here is cm. So you have second square cm. But you know, second always goes with meters. So you can convert the down one to meters. So you can have second square / meters. So your slope is also 1.311 second square per meter. So they asked us to evaluate K, and that is the K. So to this, we have come to the end of this video. Like, comment, share to others who need it. Thank you, and I wish you good luck. Bye bye.